Hello, welcome to the 2021 E-Day presentation for the Power and Energy Institute of Kentucky. My name is Evan, and I'm going to be guiding you through our virtual demonstrations this year. First, we'd like to show you a short clip featuring video from the 2020 E-Day on UK's campus, prior to the pandemic, highlighting our in-person demonstrations. Then, since this year's E-Day is virtual, we've created some virtual demonstrations using the video game Space Engineers. These demonstrations will cover renewable technologies, including PV panels and wind turbines, and how they may be incorporated into today's power grid. We hope that we'll see you again in person in 2022. Hello, and welcome to our virtual demonstration of an electric power grid. Traditionally, there are 4 stages of the electric power grid. This includes generation, transformation, transmission, and distribution. Beginning with generation, often we have fossil fuel power plants that include coal, natural gas, and oil as fuels that generate electricity. This is then transformed by transformers within a substation. This allows for higher voltages across transmission lines, which are these steel structures here that you often see alongside roads and such. Whenever you transfer power at a higher voltage, we're able to reduce losses across the lines. So once we've generated the electricity and transmitted it to a location near the consumer, consumers being residential houses, commercial hubs, or factories, the voltage is then again stepped down by transformers within a substation or series of substations, and then distributed alongside these distribution lines. Nowadays, generation sees a lot more diversity and versatility in the technology it uses to generate electricity. We no longer just rely on fossil fuels. We rely on hydropower and even solar PV power, as well as wind turbines. Both of these technologies have advanced significantly over the last few decades. Although they do still have their obstacles, such as intermittent behavior, since the sun isn't always up and the wind doesn't always blow, there are many solutions to integrate these into the grid to make them a reliable generation source. These include batteries or demand response solutions. These solutions help the operator, the grid operator, coordinate these generation technologies such that power is consistently delivered to the consumer. So solar PV or solar photovoltaic panels as a generation source can come in different scales. Utilities can make farms, sizable farms, such as LG and KU's solar farm or EKPC's solar farm over in Winchester. At this large scale, these panels, the power produced by these panels, must be transmitted just as the power produced by fossil fuel power plants along transmission lines. Now, at this level, we reach peak power production when the solar panel is directly facing towards the sun. To achieve maximum power throughout the day, we can enable a technology called solar tracking. This technology is implemented in two different ways. Some are set toward a timer, where we already know where the sun is going to be throughout the day, so the panels are adjusted throughout the day according to that time. Or we have sensors on each of the panels, which gives data to the panels to move in coordination with where the sun is throughout the day. So you can see these panels have the solar tracking enabled, and they are moving to track the sun. So as I said before, solar PV can come in different scales. At the utility level, or at the distribution side. Now, when it's at the distribution side, there is no need for it to transmit across transmission lines. Individual homes can actually use the power generated by these solar panels on the rooftops. And in more complex situations, in a community, homes can coordinate with each other. So say one user does not use as much electricity as the next. They can share that power locally to reduce losses. Solar PV is not only used to generate power for houses and communities, but can also be used to power vehicles. This solar car example is not unlike the UK solar car that we have at the University of Kentucky. The UK solar car team currently operates and maintains a sixth-generation vehicle called the Gato del Sol 6. In 2019, they achieved the all-time track speed record for solar car electric vehicles at the Circuit of the Americas in Austin, Texas. Like solar PV, wind turbines can be installed at different scales. At such a large scale, these wind turbine farms are often located along mountain ridges or in plains. Since they can operate day and night, the intermittent behavior actually comes from the fact that wind does not always blow. So we need to have them installed in locations where the wind blows the hardest and the most frequently. Alongside this example of onshore wind turbines, there is also offshore wind turbines installations, which are performed a bit differently. There are a few different ways that they can be installed in the ocean, floating, uh, tethered, but in the United States, we currently don't have very many projects with offshore wind. Countries such as Denmark and England, with plenty of available areas for these installations, often take advantage of them. Although wind turbines are scalable and there are smaller installations available for purchase, they are not as adopted as PV panels are at the residential level. Simply, solar PV is more effective and more cost efficient than residential level wind turbines. Some farmers with enough land have some smaller wind farm installations, but currently at a residential community level, the technology just is not caught up to solar PV.
This video was organized as a joint initiative between SPARC, the Power and Energy Institute of Kentucky, and the new student branch of the IEEE Power and Energy Society here at the University of Kentucky. Footage supplied by LGE and KU is greatly appreciated. Thank you for attending the Power and Energy Institute of Kentucky E-Day booth. We hope this summary of electric power engineering and renewable energy projects has inspired you to continue learning.